So, good day. We'll be attempting the advanced question of our CAD Sunday. So, it's just a continuation of our intermediate question, a test of your ability to understand engineering principles and then apply it to specialized scenario. In this sense, we have a range that we are asked that we got the factor of safety to be around 2.5, and then we are to reduce the factor of safety of this range to 2.0 and also reduce the mass. You understand? We reduce the mass 15% without making sure that our factor of safety is 2.0. So, firstly, let's go to the previous exercise. So, this is what our range looks like. We did an FEA analysis of this range, and you could see this is 0.25. So we have to reduce our factor of safety to 0.2. You understand? Oh, I think so. I think it's a mistake from me. I was supposed to say 0.2, not 0.25, and I put 2.0. So it's a mistake from my end. So, but then let's continue. So when you look at this, how do you make sure that you reduce this? Firstly, you have to think tinker with the weight, with the mass. So to do that, we'll go to our model. Sorry, static. Sorry. To do this, we want to reduce the weight. If you look at our plot, from our plot, let's look for our stress plot. You can see that from our stress plot, these are the places you can remove. You cannot remove from all these places. Let's check what is the mass. Let's evaluate the mass of this particular. So the mass of this is around 2.49 gram. So we need to reduce this 15% of this. So if you know your calculator, so if you reduce this by 15%, so 15 divided by 100 times 24.19. So we should reduce this up to this value 3.6285. You understand? By 15%. So 15% of this is this. So reduce this from this 24. So minus 24.19. So we should reduce this to this point. Don't forget about the minus we have here. It's because of the way. So around 20 ish is what we are supposed to be reduce our mass to. So how do we reduce our mass? Where are the best place to remove material? You start looking at this. These are the best places to remove material. If you try to remove material here, you would be distorting the shape, and then it will not be able to bear the particular load again. So let's tinker. So first thing for me, what I would do is to come to this place, come here. Okay, let's go to model. And then since we could remove material here, come here and then create a slot. Then create a circular slot, whichever type of slot you want to create. All depends on you. So for me, I'll create this. So for now, let's just pick a particular dimension. Let me make this 40. Let me make this from here to here. Make this, let's say, 5. So I'm going to extrude cuts one side. Extrude cut plan. Let me make this 3 mm. May not be the best thing to do, but I'm just experimenting like you. So I'll mirror this in the other side. I have to look for the front plane. Okay, so if you look at, you have to know the center. So click on here and click on this side to get the center plane. So I created the center plane. Now it's easier to mirror. So on that center plane, what do I want to mirror? I want to mirror this cut. So now that I've cut this out, let me measure, let me evaluate my mass again and see mass property. So you can see my mass property is around this. So I've reduced my mass from this to this. So I can now come back here and say, okay, let me run this again. Run my analysis again. Yeah, you can see I've run my analysis again. Now check my factor of safety. 0.29. 0.29. So 0.29, you can see it is below. Let me see. From the question, our factor of safety should drop below 2.0. So it was supposed to be 0.2. So it's a mistake from me. So from this now, we should be able to, you can see we've been able to achieve 15% reduction in mass, which is what we did. And our factor of safety, we've been able to increase our factor of safety. But the idea was also reduce it. So let me go back to